As mentioned, my name is Daniel Scuba. I work for the European Space Agency based in Darmstadt, Germany. I'm here with two colleagues, and we're hoping to bring to you some really good information on how ESA is involved with a key topic, VR and AR. I would like to begin by introducing my first colleague, Bianca Hoersch. Bianca is ESA's Chief Digital Officer, and she comes into this current role with quite a good deal of experience, both on the operational side. She has formerly been the mission manager for several of our missions, most recently our Sentinel-2 mission, which is returning some absolutely fabulous, primarily optical data. It's orbiting the Earth as part of the Copernicus program run by the EU. Formerly, she was involved in ensuring that Earth observation data from multiple missions was made available, and particularly in combination with some of our partner agencies, JAXA, NASA, and some commercial data providers as well. So Bianca, thank you very much for joining us this morning.
Thank you.
And of course, Thomas, I don't think requires much more introduction. That was an excellent keynote, thank you very much. And as mentioned, Thomas currently holds the record is for a European astronaut in space of 350 days, as was mentioned. And I'll just point out, it's actually 350.2.
Oh, you know more than me.
8. it's actually slightly more than 350. So thank you very much for joining us this morning. We'll get right into it, and my first question would be, Bianca, do you want to begin with an opening statement?
Absolutely.
Yeah,
so thank you very much.
Yeah.
Hi, everybody. I can't see you. It's so bright up here, but I see some of you in the first row. Thanks for the interest in this discussion. Maybe a short introductory note. We are the European Space Agency, and we are providing actually quite uniquely, if you compare it to other space agencies, a broad range of data that might be really, really interesting to the business, to the work that you do. We're combining data coming from navigation, from telecommunication, Earth observation, exploration, science, plus all technology that is around everything that we're doing in space, and that Thomas has so brilliantly presented already this morning to you. On top of the ISS, manifold satellites, so there's plenty of technology and data coming from all of these missions that can be explored by you. And the good news is this is publicly funded. Our member states give us this money, public money, which means the data are available freely. And this is massive data, and I think that's something that we'll elaborate in this panel.
Mm-hmm. Good, thank you very much. Thomas, do you want to begin with an opening statement, or shall I begin?
Yes, with pleasure. I tried to explain to you already where we see really big advances in the objectives that we have in future, extending our reach into space, either in an indirect way, and if I say indirect, we understand that with the help of robotic systems, sending robots into the depth of space, automated system to acquire this data, and direct means to extend the reach of humans. Now, I think one big commonality that we have here and that Bianca already addressed is, the visualization of data. As I mentioned before, one of our main tasks still, while we are working on ISS, is to generate or help to generate all the scientific data. And of course, the way how then it sinks into all these various applications on Earth, be it in material science and so forth, relies to a large extent on the way how we can process it and how we can visualize it. So this is indeed one of the main commonalities. In terms of volume, we are, compared to Earth observation data, it's comparatively small what we are producing there. But of course, we have very common interests here in finding new applications and using all these developments in the field of digitalization, of augmented reality, of introducing artificial intelligence in all different ways, also in areas where there probably have been classical different solutions. What I mean with that, just to give you an example, in order to control a rocket that it flies along its trajectory, you have closed algorithms that you can derive from the control laws. Now the question is, can you optimize that? Can you make that more streamlined, more efficient, and so forth, if you are introducing different kinds of solutions by using artificial intelligence? So there is a vast area of applications. Of course, our colleagues are working on this interface, let's say, between the data that is given from sensors, processing it, and then converting it to control actions. And in this domain, we see a lot of application, and of course, as I said before, in the human-machine interfaces, just interacting with these machines with voice recognition, getting data back in a kind of augmented or virtual reality, however you are the specialist, however that is called. And I think there is really a huge area where we can advance from the space domain also in the applications here on Earth.
Thank you, Thomas. Before we carry on, I would like to mention that I hope very much that at the end of our talk we'll have time for at least a couple of questions from the audience. My first question I would actually like to pass to Bianca, and in your role as Chief Digital Officer, could you give us an idea as to what are some of the data sets coming from ESA that actually could be available to the industry or to even to individuals?
So I think I said already in my opening statement, it's a huge variety. Let me just give a few examples, and I think we'll have some videos later also. Let's start with the biggest data set that we are distributing, that we make available, and this is Earth observation data. We have a fleet of satellites, currently 12 satellites that we are flying, that are capturing various features around this Earth. It's about what is growing on this Earth, so what is happening on the Earth's surface. You could measure vegetation growth. This could be very relevant for agricultural applications. This whole topic around smart farming, where we would combine Earth observation, but that and also with navigation data, with telecommunication data, where you can go into all of these applications of smart farming. You can provide probably virtual augmented reality in order to address these topics. Where do I put fertilizer? How can I improve my growth at the same time have a sustainable management of this agriculture, not to waste energy or to waste natural resources there. That's one part. Then the whole area about the quality of our air, the water quality of our lakes and of our seas, this whole discussion around the plastic that is in the ocean. We can't see that straight away from our satellites, but we get a good idea and understanding of the currents of our ocean, of the salinity of our ocean, the heat flow of our ocean. So this whole thing, how the interaction between us and our planet is happening, and what we do to our planet actually. We have a whole lot of data on this one as well. So this is about Earth. Then comes the whole range about, we have plenty of data coming from our satellites around what's happening close to Earth, and that's actually probably a very interesting topic also if you look into the area of gaming or visualization, this whole topic around space debris. It's getting quite crowded up there in space, and you see plenty of new players on this market are launching and flying satellites. So there is plenty of information and data around space debris, all little pieces or larger pieces of satellites, or even satellites that don't operate anymore, flying in a low Earth orbit around our Earth, which make it pretty crowded, and also there's lots of data. And then we go the next step, we talk about our solar system and the universe. We have missions, for example, Gaia, that is mapping the stars in our universe. On a daily basis, we get data about 70 million stars and their position and their interaction, the way they move in the universe, and this is all fantastic data. Plus on top navigation data, telecommunication. So it's plenty of data out there, and it's really, we can just encourage you, have a look in these data, combine them. I think the added value comes when you combine them all, to combine them also with data in situ from Earth, and then you can probably create any fantastic benefit. And that's what we're looking for. We're looking into new communities. We know the data that we have. We know what we could probably do, but we are lacking the experience on the new technologies, and that's what we would like to learn from you.
Yep. That's thank you, Bianca. So one of the points you mentioned really catches my eye. Of course, is space debris. We've all seen the movie Gravity. Okay, that was at least somewhat metaphysical, but the reality of the situation is increasingly dramatic. And perhaps, Thomas, Speaking to an audience of application developers and creators of new usages, when we're talking about space safety and the idea of space debris, where would be some of the needs that we could further communicate and further inform? And I'm a PR guy, I'm not just talking about communications with the public, but our partners and industry and our politicians. Where are some of the needs when we're thinking about space debris and some of the risks for spaceflight?
There is a very good analogy, and that is air traffic management. I think you are all aware that the skies are getting more and more congested, definitely over Europe. If you look about the amount of flights that are taking place in European airspace per day, it's quite remarkable. If we would be still on the status of, let's say, 20, 30 years ago, it would not be possible to handle this amount of traffic. Now, the same or a similar trend is visible in space. Daniel, you just mentioned space debris. We are facing a problem that is getting more and more serious. We have to do collision avoidance maneuvers ever more often per year in order to avoid debris, to maintain the safety of our satellites. So, where is the application? First of all, it is a very fundamental problem of sensors, because today we are only capable of detecting debris parts up to a size of about 10 centimeters with radar, and probably to a little bit smaller size with optical telescopes. Of course, if you want to avoid the debris, you need to know where it is. Otherwise, it doesn't make sense. I mean, you cannot avoid it. So to see the debris, but once you have it, it's quite a complicated process on Earth, and you need really a team with a lot of computer tools to decide when is the right moment to make a collision avoidance, and you know, what is the right collision avoidance maneuver. And that is exactly the point where I think we could really use a lot of more developments, maybe coming again from the area of artificial intelligence, to help to manage this traffic. Also, we need to understand that today we have about a total of 4,500 satellites in orbit, of which about 1,500 are active. This number will drastically improve over the next years. We all have heard about the new constellations that will come up, Greg Weiler, OneWeb, about 1,000 new satellites, and there are others which are intending to send up thousands of new telecommunication satellites within the next less than a decade. So this problem becomes more and more challenging, and I think the only way to solve is to increase the autonomy on those satellites on orbit to really avoid each other and to keep these systems available. So that gives you a kind of impression, and again, here you can say, apart from this autonomy to avoid, to detect the debris, the visualization for those on ground who have the responsibility to operate these systems safely, to visualize that is also quite a challenge. Today you're two-dimensional, you see when tracks are crossing. That is of course a very simplistic way of presenting it. In view of the scenario that I was just drawing, there are also big challenges in the way how you visualize the traffic situation in the altitude range between 400 and 1,200 kilometers above the Earth.
Thank you, Thomas. Bianca, you mentioned some of the data sets that can be made available. What's the mechanism for getting access to these data sets? And of course, it's not only with ESA, it's also with other organizations. It's with the EU, and it's broader.
Yes. So our member states have decided that all the data that we provide from our missions are free and openly available. Mm-hmm. All our data are online. There are different mechanisms to get to them. That's maybe something we can provide offline afterwards. If you go to our web pages, you should find it, www.esa.int. There's different mechanisms. You register, and basically you can access the data, you can download the data. We're currently also working on a new scheme of how to access these data. In the past, we've been pushing the data out. There were users registering to us, and we were trying to make these data sets available to them. Today, we are roughly at a daily data rate of about 30 terabyte of data.
30
terabyte
wow.
per day. So this is, I mean, this is massive data, and that's also something that we, and that's say roughly from the missions that we're operating today. If we look in the prospect for the next years, that's going to go. I mean, that's going to go so steep and sky high. We have to think of new schemes of how we make this data accessible. So we are reverting basically our data access scheme by building up. On the cloud-based platforms where we will put this data, where the users can bring their additional data wherever they might have them from, bring the algorithms and allow to compute on online platforms, because we just don't manage to push out these data volumes anymore to the users, and it would mean if we did that, the users would have to build up a huge storage and archiving infrastructure at their end, so that we have to rethink that. So that's currently the place. It's online, you register, you take the data, but expect there's going to be a change. We will go towards this mechanism of having online platforms.
Right. Well, Thomas, as in your current role as interagency coordinator on behalf of ESA, you're meeting routinely with our partners, with NASA, with the Russian colleagues. And of course, what we're talking about here is touching on the topic of open data. Do you see that the other partners, the other large space agencies are also making some of their data open, that there's a growing willingness for this?
Yes, there are actually two fundamental trends. I think in the domain of science, of climate research, there is definitely an openness, there's an exchange of data amongst all the agencies, because it's our common interest.
Right.
Also the research I was talking about that we are doing on board the International Space Station, it's not closed. I mean, yes, the primary investigators have the right of access for a certain time because they want to make their publications, but thereafter it's really open to everybody. So that is one side of the coin, and I think that works, and I knock on wood today very good, and I think we should do everything to maintain it. The other side of the coin is, of course, that we see an increasing commercialization on orbit. And commercialization means competition, and that is nothing bad. I mean, competition is not by itself anything bad. It's good, it's needed, it inspires, it helps to decrease costs and so forth. But what comes along with it is, of course, being a little bit more protected, which is understandable. I mean, if a company uses this environment, space, to optimize a certain production process, obviously they have invested in it, and it is a proprietary information. So our challenge is now coming from the side where we actually allow access for everyone to the data, coming from the scientific side. We need to take measures to allow the commercial, the new customers, that their data is protected and that only they can access it. And I can tell you, we already tried since many years to foster and to support a little bit this development in Europe. It's not so easy, it takes its time, we have some cases. But for example, in the area of the pharmaceutical industry, it's very difficult to get them on board. And one of the reasons is not only that they are, well, usually quite conservative, they have the research labs here on Earth, but also they fear, they are not yet convinced that we can really protect their data if they make an investment, which is huge, in using this environment, that only they have access to it. So those are the two components, and we definitely need to take care of this commercialization and take respective measures.
Right, right. Bianca, you've given us an overview as to some of the data sets and how to get them. Could you give us a couple of examples?
Yep.
And I think you brought some videos.
Yep, exactly.
Yeah. And maybe the first video would be
the one on Earth observation. I think I'll go here, otherwise I don't see what's
the,
being shown.
the Earth
Perfect.
video. Yep.
So what you see there on the right-hand side is basically just a subset and a collection of some of the data that our satellites provide, and you see the various measures that they take. So there's plenty of things around the composition of the atmosphere of our Earth, also air temperature, production on vegetation and water vapor, on ozone. We have data about land surface temperature. All of these data streams, and what we're working quite hard on to make them spatially consistent and to co-register them. That's actually quite some work that we're involved in. Then when you look, this is of course not static data. This is data our satellites are revolving around Earth, so you get typically every 3 to 5 days an update and refresh of these data sets. So we're building up long time series. You can build up seasonality throughout the year, but you could also go back in time series. And I don't know if you could go back to that video and have the second slot, around 2 minutes that should be. Then you can also go, and if you have a long enough measurement over the time series, meaning if our satellites fly long enough, you can see the course within a year, so you can see the pattern and the change of this course during the year. And you can also start to recognize, are there trends, are there changes? So this whole discussion on climate change, we're able with our satellites really to put some measure on it and to derive trends, and you can see that very nicely here. You see the temperatures here, and you see the deviations from the mean temperature. So the big red blobs give you an information on where are extreme events like drought, or where there are extreme heat events like we had this summer. So if we take these data, and you can filter out these data, and I think this is really nicely visualized in a 3D sense, and this is where we need the help from you guys to do this better in future and to visualize the signals that come from our data. And then just a second example that we've brought for you. This is now going out to the universe. There is the Gaia data set that is mapping the stars in our universe, so you could go and visit any star. We have in April just released now the second data release of Gaia. Up to now we have 1.7 billion stars mapped, and the measurements go on a daily basis. And this data set is, again, it's available. You can access these data, you can derive the various parameters, you can visualize the universe, and they are 3D ready. So these data sets you can take, you can see the movement vectors of all these different stars. I think this is probably one of the data sets that you can fantastically use in your various applications. It's open and free, and yeah, it's there for you. Take it, try it, work with us, tell us what you think, tell us where you think we should improve the stuff that we are providing, and yeah, we'd be happy for your opinion.
Wow, Bianca, those are very impressive videos, and so I understand, they're great videos. Anyone who's a science geek loves that, but for example, with the Gaia data set, this is for real astronomy. This is not just for entertainment. We can actually do some real science and some real analysis for a professional level astronomer.
Yeah, absolutely. I mean, this is not just done for visualizing it and finding it nice and flying through space. The first and primary purpose of this is to get a better understanding about our universe, what is happening, what the research are, where do we come from, dark holes, anything that is related to how did the universe, how does it exist, what are all the questions that we need to solve. These are the data that help us.
We're almost at the end of the time for our stage chat, but I would like to hopefully open up the floor for just, even if just for a couple of minutes, to any questions, and I could happily pass over the mic to anyone who would have a question for either Thomas or Bianca. I just can't see if there's anyone at the front or back. No questions?
Don't be so shy.
That's fine. Then what I would do is I would ask our speakers if they would give a final summary statement as to what you're hoping to see in the future, and we'll finish our chat.
Yeah, absolutely. Maybe just one final remark in that direction. Thank you very much for being here. There's plenty of data out there. Try them. We are not only providers of data, but as I said, we are also very much interested in understanding and learning what you can do with these data. So there's also some announcement of opportunity, some call for opportunity, and one of them will start on the 15th of January. There's a Kickstart call, so if you search that on the web, it's Kickstart ESA Virtual Reality. There's actually also some funding available where you can go and propose new ideas, what you can do with the data that we have from our missions. You would need a supporting letter from your national delegate. There's a list of these people that can be contacted, and then you apply for funding, and that can be up to 60,000 euro per project. So that's quite considerable funding that you can get from us. We're trying to get new applications in this area, and we'd like to work with you.
Great, thank you. Thomas, final statement. If you're flying a future mission to Mars, what would you like to see when you're on that craft?
Yes, I mean, first of all, we have to really take some hurdles in terms of technologies in transportation, in radiation sheltering, once we are getting beyond the Earth's magnetic field. But obviously, the interaction between these highly integrated systems is one of the biggest challenges. The classical way how we are operating, maintaining the station today, this will be different when we are once on our track. And maybe also to add to what Bianca has said, you know, spaceflight has become much more part of our daily life than many of you might be aware. So I can only encourage what Bianca has told. Please be aware, there is a lot of data coming that is relevant for our day-to-day life. It's not only the weather forecast, it's more and more navigation. Think about autonomy in driving that won't work without very precise satellite navigation. Telecommunications, we are discussing in Germany to have wide distributed access, wide bandwidth access in future. The possibility to have wide bandwidth access via satellites will become a factor. So keep that in mind. Space is getting more and more part of our daily life, and therefore we are hoping for your support, those who are working in the area of digitalization. Thank you very much.
Thank you very much, Thomas. Bianca, thank you. Thank you very much for joining us today.